as God. But Mata, Pita, Guru is Daivam. So when we were working for foreign companies, they were our guests, but we treat them as God and we do everything. But when we do for our own country, our mother India, it's much more sweeter. So yesterday on the Republic Day, our sock went for the tape out. And thank you, sir. Without your support, without all these initiatives, we would not have been here. And most important aspect I want to say is like, okay, when we do for our country, we don't do it just a replacement. We do the world's first. And ours is the world's first networking sock that is based on RISC-V. You can Google it and you can search it, but we have taken the leap around and we have made it together. And thanks to my extended team, DLI, MIT, ISM, everybody was supporting, and EDA, everybody was supporting to make it happen, and we have achieved it. We should be having the chips in our hands in another 4 months. So what is the market we are looking at? We are looking at close to 100 million units. And because every home, the internet that you use comes in a white box, which gives a fiber and then a Wi-Fi. You connect all your mobile, laptops, smart TVs, everything for this. And it is going to collect villages. Already government has done BharatNet, given the fiber connectivity to every villages. Now with our SOC and with our solution, every home will have access to broadband internet. We are already empaneled with BSNL and we have already signed up with several large telecom operators who are rolling out this today, where they don't have any other opportunity except to use whatever is available in the market today, which will be replaced. And thanks to the semiconductor mission, it really helped. Sir, I have one request which I would like to place. So this is our Vihon SOC. This is our IP. 40% of the IP is indigenously developed, and this is with CDAC Vega core. We have thoroughly tested it, and it's production ready, fantastic IP, and we are able to achieve whatever goals we kept with it. 100% production ready. 60% of the IPs are standard IPs, sir. So my request in DLI 2.0, if there is a way we can have an industry academia collaboration where some of the standard IPs like USB 3.0, PCIe, SPI, eMMC, if we can have it jointly built together in India, then all the DLI companies and all the Semicon startup companies, they can reuse the same IP, then each of us licensing the same thing. Right now we are buying from various vendors, sir. USB, how many vendors would be there? Sir, USB, what we have found is, sir, at least 4 or 5 vendors are there. But typically, what we have seen is like when the fab house is giving the licenser, they are giving at a very discounted cost. But if you are going to buy from an IP vendor, the cost itself is highly prohibitive. What is the type of effort will be required? How much effort will be required for? How much effort will be required? Time and effort will be required for indigenously developing these IPs, standard IPs.
When we started, right, we did talk about the USB IP. We do have a multi-protocol NRG SerDes, which is kind of backbone for this one in TSMC 28 nanometer. Certainly say like this kind of effort, right, where all the indigenous IPs, what startups they have designed, if it can be taken to the production, brought to the DLI repository.
No, let's say all these standard IPs. Suppose we make a mission in our DLI 2.0 and take a call that let's say we'll develop all these, and after that we'll mandate their use in all the chips that we use in India.
Actually, we have the plan to build the not about building the IPs, but silicon proving. I think that's what he was mentioning.
Silicon proving will take some time, but we can always work on it.
And the standard keeps evolving, so there is a maintenance mode, like an AMC mode of those IPs, critical IPs. Everybody will need PCIe, like he was mentioning, USB, Ethernet, some SerDes, whatever form of SerDes they need. So, but keeping them upgraded or updated is the bigger challenge.
Can a team from these smart brains a small team of 3 or 4 persons can you collect?
Yeah.
As
Certainly.
3 or 4
Maybe I
persons?
think I can give the answer directly. If we put this thing, sincere effort, right, in about 24 months to 27 months, we can have a Semicon
That's great.
proven.
Let's take a target of 24 months then.
Yeah.
When you come to USB 3 PCI Express and those kind of IPs demand good, extremely high speed analog designs. And what I have found is in India, the capabilities are minimal. And also for silicon proving the analog IPs, each of the processors, for example, we are targeting 12 nanometer. We purchased the 12 nanometer SerDes IP, both for PCI Express and USB 3. There can be a team building IPs, but proving it on each of these targeted technologies is time consuming, and there are multiple technologies. For example, UMC has their own technology, TSMC has some 3-4 multiple nodes. Proving it for each one of them is extremely difficult, right? You might be able to
Tell me, this is a journey that we started 3 years ago, just about 4 years ago, right? January 22. Within 4 years, we are at a very significantly good level of achievement. And this is a level where we can now take off. If we put together a larger team, and if needed, we can have some collaborations also. In Davos, this point came about analog, exactly the way you have said. This point came about analog IPs are going to be very, very important going forward, because when you go to the real world applications there, and especially in the strategic sectors, the analog IPs are going to be very important. Suppose we make a request to all of you and we support it fully. Whatever support is needed, we provide that support. Maybe in a period of 36 months, we can have a suite of analog IPs coming out of our country.
It is definitely possible. I think I know that there are skills available in the country. Only thing is we need the collaborative effort.
Sir, and we can also, there are so many good people out there in practically every large semiconductor company has either CTO or chief designer as people from our fraternity, people of Indian origin. They'll be very willing to support us.
Sir, if I may add one more statement, sir. So, in Agisam, the person who is heading the ASIC team who is working on it, earlier they were the co-founders of a company called Palika, and they built the USB and the PCIe IP, which was later on spinned off and got it sold to SMSC, and which was later on spinned off and sold it to Microchip. So if you look at any laptop or any desktop where they are using a USB or a PCIe, actually it was built by this kind of team. So if MIT and DLI and Ministry can set up, we'll be more than happy to bring in the right kind of people who have already worked on it. As a group, we can make it for the country. So thank you very much. With this, I conclude my speech. Thank you. Jai Hind.
Thank you, Sridharanji. I invite now morphing machines, Ranjini ma'am, to kindly come and present the activities that they have been doing. So they are working on a multi-core accelerators and they are in advanced stage of proving their designs now. And please.
This is Mindrose presentation. Should I?
I skip my group.
Thank you everybody for giving us this opportunity to make this presentation and show and summarize our progress with DLI as background. But morphing machines itself has a little bit of bigger background, in the sense morphing machines was born as an incubator at the Indian Institute of Science, and Professor Nandi, who is in the audience here, was the original founder of morphing machines. I very soon joined him to run this company, right from naming the company as morphing machines. That is, we wanted to, it was our dream, I would say. I won't even call it vision, it was a dream to say, can machines morph themselves at runtime automatically, looking at the application needs. That's why the name morphing machines. And then we started with clean slate, completely indigenous, right from concept. Very, very fortunate to have PhD students and master students of IISc who primarily work with Professor Nandi to get the concept. Okay, it has to be a many core processor. What's the kind of core? How can it reconfigure itself? Because once we produce in silicon, everything is written in stone, if not sand. So that's how we started. And we very soon named our processor as Redefine. We very consciously named it as Redefine because we believe that we can redefine affines between software and hardware. So Redefine, to be short, is a software-driven hardware which can reconfigure itself at runtime. We did a lot of research for the first 15 to 20, I would say 10 to 12 years before we got into relationship with Safran Electronics from Paris. That gave us, even before that, we were engaged with Anurag, okay, to prove the concept, to prove what we had in mind. Safran came as a breakthrough for us in 2015 to 2020, wherein, they loved our processor and then said, okay, let's have simulation runs of the integrated modular avionics. Yes. Yes. So they were looking at integrated modular avionics and they were interested in this. That sort of gave us an experience to polish our processor and get to the current version of Redefine. Then came COVID, but then good things happened during COVID for us. First was SAFL, the Semiconductor Fabless Acceleration Lab, which was Government of India and ISA initiative. We probably had was the fortunate first to use free EDA tools. We were penniless. That really, made us go, just take 1 foot off the ground. Then came blessings with mighty, both CTS and DLI. People have already talked the things that have happened in through DLI directly. Indirectly, what it helped us is to make believe in the Indian investors, saying, okay, there is some company called Morphing Machines from India. Is it going to be a reality? Okay, they have the backing of Government India, Government of Karnataka and India. Let's put some money. That's how, we started to grow. How do I? No, sorry. So from a team of students, we were single digits till about 4 years back, but now we are very proud to say that we are a team of about 60 people and spread over 3 centers, 1 in Hyderabad and 2 in Bangalore. So we have teams of RTL, DV, verification, simulation, PD, product and system software teams. One of my colleagues, Harish, is from the software system. And anybody who is interested in a live demo, we have, since we could not carry our FPGA system, we have software simulation running on his laptop. We just walk in front of his laptop or ask him to turn the laptop and your face will be detected. So that's how it is. So let me just go through this. So we believe we are one of the first globally to have this indigenous No, we have a team waiting back in Bangalore to show actual live demo running on FPGA, but unfortunately the time is too short. But then this is software simulation. So I have already, I think, talked most of what is there in this slide, but I just want to point you to the fact that above 90% is all indigenous. Of course, PCIe, DDR, those are the things, that we are dependent on others. Others means outside India. Also, what we planned is, Redefine is a very scalable architecture. So we have a template. From the template, we can say, okay, do you want 16 cores for an edge AI, or do you want a 1024 core for a data center? Since all our modules are unit, module, and integrated tested, we spill out, I say on the fly, but actually not on the fly, but from a template architecture, we can choose the modules. Since it's all completely tested, we build the architecture. Turnaround time is very, very low. That is one of the key things in the way we have architected. So our focus areas are going from edge AI to data centers, but this year we are concentrating on data center because we can't really run thin, We can say it's reconfigurable over several domains, but we need to focus on one, and that is the data centers. In particular, we are looking at something called fully homomorphic encryption, where the data in encrypted form can be analyzed. The downside of it is the computations blow up to 10 to 3 to 10 to 5. So what is the kind of architecture which can do it? We believe Redefine can do it. That's what we are currently exploring. We have a huge market within India and outside India. If I can ask Professor Nandi just to say the numbers, that will be.
Thank you. We noticed that typically the market size annually is about 120 million in this kind of FHE-based encryption, and we are already in conversation with 3 banks, and we are looking for a joint POC with RBI, SEBI, ICICI, and HDFC. And we also have 2 consumer data centers who have confirmed interest, that is SIFI and NextGen.
So it's not only the finance or the banking. All of us want to keep our bio data, the DNA data within ourselves. So it has huge impact on the healthcare analysis also. So the data goes as encrypted data to the analytics center. Analysis is done on encrypted data, and the results are also sent back in the encrypted way. So that's what we are looking at. I don't want to press the wrong key, but sorry about it. Oh, what is that? Okay, sorry about it. Okay, so as we talk today, May is the time frame where we are going to get the first test chip out, and going forward, we are planning one next version of Redefine every year with all the markets that I have just mentioned. And with DLI, I need to mention it here, we are about 50% through the journey of the whole, from design, implementation, testing, simulation to tape out. And May is the time frame we are looking at, rolling it out on a 28 nanometer TSMC. Going forward, it will be 12 or less than 12 nanometer, probably with Samsung, that we are in talk with Samsung. So we will be fully operational sometime in 27, 28, and we want to really start getting global. Carve a niche for ourselves. GPUs are good in certain aspects, bad in certain aspects. CPUs, FPGAs, all have their market. We want Redefine also to carve a niche for itself in the global market. That's the vision we have going to 2030. So with that, I think I have much more exceeded in the time I was allocated. Thank you for this opportunity.
Thank you, Ranjini ma'am. The next 2 applicants, DLI applicants, are working in a very, very critical and strategic area, and that is video surveillance. So let me first call Shashwat from Mindgrove Silicon. Mindgrove is based out of IITM, and they have been developing this solution for the last couple of months now. So please, Shashwat. Good afternoon, everyone. Good afternoon, sir. So, Mindgrove is a fabulous company out of IIT Madras, and we work on systems defined around the Shakti microprocessor, which was developed at IIT Madras. Our first chip, which you see here, is the secure IoT device. We call it S2401. I'm holding it here actually. This is the prototype chip, and we have gone to production, and we will be in the market with this chip in the next few months. This was done before DLI, so yeah. Thank you, sir. The second chip over here, this chip is ours. This module is also ours with other chips, which can be given as a pack to the customer. Customized for us. Can you take it off? Yes, sir. That's very hard. So the chip is ours. The module is also designed in at Mindgrove, and it was manufactured in India. This chip is designed, it's a high performance microcontroller. It is designed to be very versatile. And the key thing over here though is that it has built-in security, and therefore it is very appropriate to be deployed in applications where security, on-the-fly encryption and things like that are critical. We are certifying it so that our customers don't have to redo the effort later. So this chip was developed just before DLI was announced, so we did not apply for DLI for this. This is the Vision SoC. We initially conceptualized this as a single chip, but now it has become a family. And the first one over here, this is DLI supported. We are using both tools and financial support, sir. This one is being built right now and will be launched late 2006, early 2026, 2027, depending on timelines. It's under active development. And this is meant for CCTVs. And this is optimized for the lower end. Now this is the second version of the chip, which is 2601, which is a quad-core version of the same thing. The quad-core is already working, but it will be put into a commercial chip after the single-core version that you saw in the previous slide. Sir? This is actually compared to the competitor over here. I did not put it over there, but is the one that you mentioned. The ISP and the video codec are internal IP. In fact, 80% of the IP on all three chips is Mindgrove IP or IIT Madras IP. So it's completely homegrown. So we had a discussion a little earlier about USB. The USB 2.0 that you see over here in this chip, that was the controller side of it was developed at Mindgrove using certain open source components. The PHY is still from outside, but the controller is ours. We hope that we will be able to move it into completely indigenous mode soon enough. So a couple of points about, I think I just want to reiterate the points that my fellow founders have made over here. The support was invaluable. This chip used so many tools from DLI to get it off the ground. We would not have had access to at least like 80-90% of them without DLI funding. And that just allows us to move much faster. It's not only a question of access, it's a question of speed. It's just allowed us to move much faster than we would have been able to otherwise. And time to market is probably the biggest thing that we have to solve at this point. The second thing is, I think the most important thing for us, my request right now is that all of us are at this crucial stage where we are proving our IP, proving our devices, just entering the market. My request is to stay the course so that we can actually prove what we set out to prove. I think it takes just this much time for us to get to this point. Thank you, sir.
I just want to make one small point here. The entire CCTV camera universe that we see, we all know that it's a big security risk for the country, it's a big security risk for all citizens and everybody. So that's why to de-risk it, it was very, very important to develop our own SoC for vision, and I really compliment Mindgrove team for doing that in such a short period of time to this level. The name that I took, competitor, so that's, I mean, that should be a target now. We should beat the competition that we did not like to mention the names, but we should be able to beat them in coming 5 to 6 months.
Thank you, sir. We have another DLI funded startup who is also developing the chips for video surveillance. So I invite Sunil from Big Indian Semiconductor.
Thank you, sir. Thank you, sir. I think we are the largest user of chip-in tools in the entire DLI program. I think we use the highest. We are ranked #1 on that part, largely because we wanted to accelerate the time to market of what we are doing in terms of commercializing our thought process. Where we are right now, we taped out our first SoC last year. It should come out into production, come out from the fab for a wafer out by March, April timeframe. We want to sample between April and June, July. Hopefully, we should be able to commercialize from July 2026 onwards. We are going specifically purpose-built SoC for, we call it vision solutions only, because when you look at consumer or enterprise vision solutions, it's largely to do with the ecosystem build out rather than just a discrete solution. You need to have supply chain done, you need to have application layers done, you need to have system integrators who understand your stack well for them to build out solutions on top. So we have given enough emphasis on ecosystem build out as much as the silicon build out. So hopefully from April onwards, maybe we will be able to present you with a camera which can actually do certain aspects which we never thought it can. So that's what we are aiming out to do. Going forward, obviously, we are coming out with, sir?
There is this word that you see, MPW, for the media friends. So, as I said, when we designed the DLI program, the first thing we solved was EDA tools. Second thing that we solved was IP, core IP, and making CDAC as the repository for, sovereign repository for core IP. Now, once you design a chip, if you want it to be taped out, how will you access the large fabs? They will not even listen to some startup, right? How do you secure that? So in our design of the program, we said that if there is any DLI startup which wants to tape out, we will support the MPW, which is multi-project wafer, which basically means the cost of taping out one chip or one set of chip is very, very high. And the opportunity cost for the fabs is very high. That's why they don't want to take from the startups and new concepts. They would like to do tape outs from big companies, Qualcomm, Intel, AMD. They would not like to do from the startups. So that's why we supported this cost also. So the three major factors why the DLI has succeeded. First is EDA tools. Second is providing the bank of IPs. Third is doing the MPW, multi-project wafer tape out process. Thank you for bringing it up.
Thank you. Yes, sir. I mean, for us, EDA tools are like infrastructure. It's like building a highway. If this is not there, I think the semiconductor dreams of several companies, I mean, everybody, I think, emphasized it. Hats off to CDAC for implementing it so beautifully, so professionally, so transparently. We've been troubling them a lot, but still we have been getting the support what we need, and that's a bloodline for us. Everybody was emphasizing on IPs and having self-reliance on control on what we're trying to do. Since we are a vision chip, all the critical IPs which are related to imaging and inferencing is what we are building out from now. The second chip which we are building and we're taping out in April, which is going to be an 8 TOPS chip, which is competing with the name which we don't want to take. That's the chip we're coming in with a power budget which is as competitive as or slightly better than that company, and building some features which are inside which will reduce the BOM cost somehow. So that's what we're aiming for. Otherwise, the current chip we have done taking off-the-shelf IPs because time to market was critical to prove to our investors, our supporters like DLI, MATI, ISM, that is also as critical. The third vector in this, which we don't regard as much, is the ecosystem partners. When I mean ecosystem partners, which is OEM, system integrators, software build-outs, third-party software which will go and sit on it, and so on and so forth. So this is what we are chartering out to plan. The only request is, like everybody has said, please stay the course. Our actual burn is now, when we are taking from MPW to full mask. The full mask itself costs about 1.6, 1.9 million. That's where we bleed and burn a lot, sir. So if the honorable team is able to support us going forward, that will be a great help. As we speak, we're also trying to close out the next round of funding. Is about 80 crores is what we're raising. Hopefully, we'll be able to announce that as, and also in that raise, a lot of big hand is because of DLI and the chip and tools. Thank you very much.
Thank you, Sunil. So next we have Vijay Muktamat from Sensemi. They are working on a healthcare SOC, and they are also retargeting their solution for Edge AI.
Good morning, Honorable Minister. Pleasure meeting you. Imagine your health data goes back to Amazon server of a Bangalore person to tell him that, the insulin has to be taken or drug-induced can happen at this point of time, right? So that requires a server either in India or external to India, right? And this is exactly what do we need it? Probably not. So this is where, the Edge AI chip with wireless connectivity. What is that wireless connectivity? A BLE should require not to send anything but process locally. And this is where we are not just building an ordinary chip, but we are building the brains into connected devices, right? And that's where the whole intent of bringing the Edge AI compute is required. And that too at ultra low power technology. We are not at, a 28 nanometer or below. We are at 40 nanometer because the 60 to 70% of the strong analog front end is what is required for medical implants and the sensor fusion, right? And this is where Sensemi is concentrating heavily to bring in the wireless connectivity as well as the brain into the chip itself. When I talk about brain, the way the accelerators are being built in today's world are all digital in nature. But where Sensemi is trying to do unique is to bring analog compute, which reduces the power substantially. And this is where the neuromorphic engine comes into picture. And that's where Sensemi is highly concentrating upon. But one other important factor is also the security, right? So that is very much required, be it your industrial IoT, be it your medical devices. And this is something which we need to have it on the chip, a secure data being on the chip as well as off the chip. And that's where Sensemi is building the first indigenized, probably we would be the first AI-enabled BLE chip, right? So probably India's first BLE chip to be coming out of India this year from Sensemi. So would like to announce, without DLI, this wouldn't have happened. And this is as recent as last week. So we got really funded with 25 crores from lead investor like Piper Seneca, which are getting into deep tech. This is very important from the investors' point of view as well. And that's where, DLI has really helped it. And of course, funds will be utilized for a couple of test chips. Sir, definitely the analog front end takes 2.5 years to develop. And this is where we are going to be there. And the patient capital is required. More investors have to come into picture. One other point I want to highlight, sir, since you talked about, analog RF, right? So that's the premium part of Indian ecosystem which has to be brought in, not for India, but for the world. Why? Because we have seen that there is back tunneling of data through Wi-Fi as well as BLE now, right? And this trust has to be brought from India to the world. And that's where Sensemi is going to concentrate upon. And we also talked about, analog IPs, which is important. Sir, I would request, if Tata is coming up with its fab, right? Why can't we have at least the IPs of analog to be brought down into that? As Jyotish said, the different technologies are there, right? But at least we should begin somewhere, right? And Tata would be the best place where we can build our SerDes, we can build our own RF components as well. And this is something which a request I would like to make to DLI as part of it. And definitely, I think just to give another 30 seconds, I was part of the Bionic Eye project in Australia way back in 2011, built a retinal implant chip. In India or in the world, there are only 2 countries which were doing that. One is US, the other was in Australia, and I was part of that group. So the implantable chips do require edge AI compute. And now this is the era from India to develop all these medical implants, the core industrial IoT as well. Thank you, sir.
Time you make the next announcement, a small request to all the startups and professors and others present here. All of you have this paper. Please use this, write your name, write your phone number on it, and 1, 2, 3, 4, 5, 6, 7, 8, whatever asks you have for the DLI 2.0. Because we are in the process of framing it. Also what you don't want us to do, do's and don'ts. Mistakes that we should avoid and things that you want. I'll personally study all of them. So please write and give it before we go for lunch. No lunch without that. Assignment.
So next I invite Arumugam Govindswamiji from Mbit Wireless. So they are based out of Chennai and they are developing a dual stack chip for Mbit for narrowband IoT and Cat 1 bis.
So good afternoon, sir. Good afternoon, everyone. So we are a fabulous. We are a fabulous semiconductor company. Before getting to the DLA project, let me give an overview of our company. We are developing a full stack 4G, 5G solution. We are one of the only 4 companies in the world advancing the 4G, 5G stack. So we developed the complete foundational IP, which includes the modem technology, the signal processing, the analog component, the power management component, entire stack. And our stack is fully certified by GCF. GCF is a global certification forum, which is essential for make sure that the product is certified so that you are safe for the network, as well as the operators will have a confidence that your solution can get into the network. Our technology is covered by about 150 patents, more than 150 patents. Out of that, 104 patents were granted and 50 in the pipeline. So this entire technology, which is the baseband, the RF, the power management, the signal processing stack, completely indigenously developed in India. So based on this technology, we created 2 separate platforms. One, an IoT platform, which is primarily targeted for low cost mass market volume product, which is fine tuned for a 22 nanometer process node. The other stack, which is primarily targeted for the mobile broadband application like smartphone SoCs, fixed wireless access, So that's tailored for 5 nanometer chip design. So today with this, India has a full end-to-end stack for critical communication, which is basically the 4G, 5G network. And this technology is basically based on the packet-driven networks, and which is the future of 6G as well. 6G is nothing but the augmentation of 5G. So this entire technology developed with a tremendous effort by the team to accomplish that. The market access for this technology today is over 100 billion US dollars, and the lead competition in this space is estimating this market to grow over $700 billion over the next year, which is annual market access. So that's a deep and scale of this technology. So based on the two platforms we created, which is an IoT platform as well as a mobile broadband platform. The IoT platform is the first chip, which is basically DLA approved project with great support from MeitY, DLA team and CDAC team. We are able to make this product, take the essential IPs we developed and transform into the first commercial silicon. So the dominant cellular technology going for IoT, which is a cat on this with fallback narrowband IoT, there is enough when the narrowband evolves. So the market access is going to evolve over 450 million units per year globally. That can transform roughly about a couple of $1 billion revenue per chip. So the entire stack has a transformation of over $700 billion over the next decade. Right? So this stack today, currently as we speak, we are field testing in all four major networks, Jio, Airtel, Vodafone Idea, and BSNL. And so again, this stack is certified stack. So we can go and do field test in the live network today. So we are working with major two top tier customers in India. We also have an agreements done for South Korea and Japan for this technology. So this is not specific to India as well, built in India for the world, which is compliant to that. Since once you get certification GCF, with covered by more than 150 patents, so that's sort of, now we are at one of the leading, we can compete with the leading firms. As you know, there are only three companies out there outside India. We are the fourth company to build the entire stack here. So as the next step, we are plan to commercialize this technology as well as take the foundation IP, deliver the complete SoC, the 5G SoC, from baseband modem to power manual signal processing and the application processing to that. So we have the entire stack built in. Now, as a roadmap, we can take one technology as a stack. So we do have the POC today. I can basically show it to you. The entire mobile smartphone POC. Today we can make phone calls to all four major networks today in India, right? Maybe I can ask Praveen to come and share the POC, the phone POC today, develop. Yes.
Is it okay now? Yes. So let me start. So, and power. And this entire mobile product is very possible. You can go right phone. This is for the phone. This is for the
Sir, we are from the team of the engineers who created the first health and food. This is the first one.
Only the entire solution like this, way back.
Way back, yeah, because they're like,
So we understand the system now, we understand the complete scale from that thing. On keep up.
because under this, the blood is
So this entire food is back because of this chemical Samsung. When do this come to college? With your support, we can do that. We have we can make 1 billion because we have still very well informed.
So we pledge this. Thank you, sir.
So the chips that the team showed are basically the chips which make the mobile phone. Entire chipset which is required, 4G, 5G, chipset required in a mobile phone is what is demonstrated today. And this is the team which had designed mobile phone chips way back. So this is a team which understands mobile phones. And 24 months is the target. You are saying that we can have our own mobile phone chipset, right?
Because we made the foundation like the slack is right? And cover
Super. Let's work on it. Super.
Thank you, sir. May I now invite CEO of Moschip, Srinivas Kakumonuji. Moschip is developing a SOC for smart power metering.
Thank you, Vivek. Yeah, good afternoon, everyone. Good afternoon to Minister Ji. I'm very, very excited to be here, and this is Ashwini Ji, very excited to be here, to be interacting with all of you. Before I talk about the project we are doing under DLI, let me give a brief overview about what Moschip is. So, I mean, a lot of companies that are actually representing here, they're all startups, funded startups. And Moschip has been around for 26 years. And the company was founded in 1999. And we were a fabless Semicon company. And we were actually producing I/O connectivity chips for a global market in the initial 7 to 8 years. And over the last few years, we've been providing silicon engineering and product engineering services to customers globally. And in fact, we were involved in more than 600 tape-outs over the last 26 years. And we worked on designs that actually went into, that were done in 180 nanometer all the way down to 2 nanometer. And as part of silicon engineering services, we've been working on turnkey ASICs, where we take the responsibility of, maybe customer actually gives us a specification or a design, and we hand over silicon back to the customer. And because we have product engineering services also, we basically support our customers on the embedded software, system design, and so on and so forth. And one more important aspect that I wanted to talk about is the learning and development center that we've been actually promoting. And over the last 15 years or so, we were able to train more than 3,000 semiconductor professionals, which are actually part of either Moschip or companies in India and abroad. And again, as part of turnkey ASICs, we've been delivering silicon to customers. There are, two projects that I wanted to bring to your notice. There is a GDB ASIC, GNSS, a digital baseband ASIC, that we did for SAC very recently. This was done in 28 nanometer technology, TSMC 28 nanometer HPC plus. Jairam, you can probably show it to Ashwini ji. So this silicon was actually delivered to SAT, and this is first pass silicon success, and it is fully functional. And to just to give you an idea about this design, it has about 500 million transistors. 500 million transistors.
This is small. This is the size of a nail. 500 million is 50 crore.
Yeah. Yes, sir.
50 crore devices inside.
This is the power of semiconductors. This is a small chip designed by our team here, MOSCHIP team. This is the size of a thumbnail, and it has 50 crore devices inside it. 50 crore devices. Right? Great work.
Yeah. Thank you, sir. And this basically goes into navigation receiver systems. And apart from SAT, we are very, very honored to have gotten an opportunity to work on our indigenous high performance computing processor, SOC, which is own processor that we are doing for CDAC. And we will probably get an opportunity to discuss about this project maybe at a later point in time. So these are two projects of national importance that I wanted to talk about as we are meeting here. And coming to the smart energy meter IC, and we call it Vision, that we are doing under DLI scheme. Again, as I said, MOSCHIP was a product company, and even though we've been doing design services, we wanted to do a product, and we wanted to be part of product building nation, and we have taken up building smart energy meter IC, and some of our colleagues were actually talking about the difficulty in building analog IP, right? Smart energy meter IC has 6 important analog IPs, and hence, what we wanted to do was, we wanted to do test chips, right, for analog IPs, and we did tape out 2 test chips in TSMC 180 nanometer, and VTC1 had 4 IPs, and VTC2, the test chip 2 has about 2 IPs, and the VTC1 IP validation, we actually completed, and we are doing characterization at this point in time, and VTC2 has actually arrived just now, and we are going to validate the ADCs that we actually built. And on the digital portion of the chip is being validated on the FPGA platform, and with the entire software and the DLMS stack. And we are planning to take this out in May this year. And also to make it completely indigenous, we have developed both the digital IP and analog IP in-house, and the processor core that we are actually using on Vijay is from Incore. In fact, our team is working with Neil and others from Incore. So that way, the chip is entirely, the IP is entirely designed, indigenously. But the initial chips, we are planning to get them done by TSMC. But because this is 180 nanometer, we are also running a parallel thread where we would like to actually get Vijay done in SCL. In fact, VTC1 and VTC2, those 2 chips, even though they were fabricated in TSMC 180 nanometer, we got the packaging done by SCL. Jairam, can you show them to Ashwini?
smart energy meter in a chip.
Yeah. So, yeah, the plan is to basically design this chip indigenously and hopefully get it manufactured by SCL in 180 nanometer and take it into production. And once again, I mean, thank you so much for the opportunity. And I'm very, very honored to be here and presenting what we are actually doing in front of you. Thank you so much.
What was your experience of taping out at SCL Mohali?
The interaction, the engineering interaction and the PDK support and all that was pretty good, sir. And the turnaround time is basically longer than what we have actually experienced at TSMC. And we also know they were basically limited by capacity, and they also ran into etching machine issues and so on and so forth. In fact, VTC1, the first chip that we did for TSMC, the same chip to validate 4 IPs, we taped out to SCL. And as we speak, those chips are being shipped to Master. Yeah. Right.
There is a very important point made here. If you design the chips and after that, how do you tape them out? One of the factors that we considered was MPW, as I explained. Now, as we go forward, as the semiconductor ecosystem is building up in our country, and as we become a product nation, as Moschip has been providing system services, but now Moschip is becoming a product company, right?
Yeah.
From services company, you are also becoming a product company. Now, to be there, we need tape-out facilities within the country where preference is given to startups in a big way. So that's why we are taking 2 steps. Apart from the MPW, which is there, in addition to that, we are taking 2 more steps. First step is we are upgrading SCL Mohali in a big way by investing about 4,500 crore rupees in it. 4,500 crore rupees we will be investing in SCL Mohali, and SCL Mohali will become the, in a sense, lab for entire semiconductor ecosystem in the country. So any startup who wants to design and validate the chip, tape it out, they'll have this facility available to them as a government facility so that our startups get a very good tape out physical production facility in the country. Also for the students. So this will be at a node which is a very well used node, but a legacy node. The second facility which will be used for taping out, that will be Tata's Dholera fab. So the Dholera fab, 28 nanometer to 90 nanometer, and SCL 180 nanometer. So in a sense, close to 80% of the chips which are manufactured in the world, or maybe 75%, 75 to 80% of the chips which are manufactured in the world, that entire ecosystem we will be able to build in our country within next 2 to 3 years. And the path beyond that is also very clearly visible, which I'll share with you in the closing remarks.
Right. Thank you.
Thank you, sir. Before I invite Vinayak Dalmia from Third iTech and DB2JS for the next presentation, I have a small request to make to all the presenters. Kindly be precise and short. We are already behind schedule, and there are still many applicants to present. So Third iTech, or DB2JS as they are known, is working on development of another key critical component in the surveillance market, which is the image sensors. Use this, or you can use this, right? Or you use this.
Good afternoon, everyone, and thank you to the Honorable Minister, to DLI, and to the entire leadership at MIT for making this possible. I think, Sir Minister, sir, you spoke about the value of the tools. So I have, in our company now, we have almost 100 designers and a global presence. When I talk to my American teams, they're amazed that the tools are provided by the government. Because in their country, that is unheard of. And if we didn't get those tools, the cost per year just skyrockets. So that is, thank you so much for that support, sir. So you made a comment at Davos on two things which really stuck out. One was on sovereign AI. And I think within sovereign AI, physical AI becomes the next wave. And you also spoke about analog. So when we talk about the physical to digital interface, analog sensors become essential. Whether we talk about drones, we talk about surveillance cameras, or other kind of applications. So we are focused on sensors. As I said, we have a global team. We are very proud to say, sir, that normally it is American companies setting up offices in India. We're a young company, but we have set up operations in NCR, in Bangalore, and all across the US, and scaling over 100 designers already. We're also very proud to say, sir, thanks to DLI, some of the C-level leadership, technical leadership from one of the largest global semiconductor companies have joined us. On Semi, OmniVision, Global Foundry, Analog Devices, and defense companies like Raytheon and BAE Systems. Proud to announce, sir, that the CTO of OmniVision, which is one of the world's largest sensor companies and the largest fabless company out of China, their CTO quit their company in May 25 and has joined us as CTO. So that's just sort of an update, sir. We are working, the product we're working under DLI, sir, is a image sensor. So that's the heart and soul of a camera. For surveillance market, we interviewed more than 20 Indian surveillance camera companies. And we realized that more than 70% of them are buying chips from a single Chinese source. And we also zeroed in all the specifications. So what we're doing is we're doing a mass production now with customers, and they have 6 modes in the image sensor in the single chip, sir, from very low light to very high speed. A single chip will be able to do that. We have contracts and customers, sir, with Bharat Electronics. We have contracts with Kane Semi, which was announced and signed in Semicon, and these are all for mass production. We also saw in 2024, you will be happy to learn that this sort of wafer, we had done a mask tape out at TSMC. And per TSMC, this was the first time that they had declared an Indian fabless company as an innovation partner. And I was personally invited to TSMC to speak and give an address. And now we're doing a mass production, not with TSMC, but with another fab in April, which is going to be for volume production. Our hope, we're in touch with Tata and TSMC. Our hope also is obviously that we bring that fabrication to India as and when that is ready. So I just wanted to give you some context, sir. There are about 10 billion image sensors produced every year, and that number is scaled.
To EDA tools and a whole set of IP cores, and we made CDAC as the sovereign repository of EDA and IP cores, and using that mechanism, we provided this big facility and a big enabler to the startup community, and that gave them one major leap into the design world, because now you have the EDA tools, you have the IP core, then you can use your team's brains and you can work on a concept and then apply for DLI. Funding becomes automatic once you have developed a concept. Otherwise, it becomes just a PowerPoint slide if you don't have the EDA and IP. So I thought that's, thank you, Arjun, for bringing it up.
Of course. Thank you, sir. So we have had a bunch of achievements. We have launched a complete range. And Prime Minister in 2022 said that he wants India to become a chip maker from a chip taker. And that statement really resonated with all of us. So I think the preferential market access would be a really big game changer for chip companies. Especially if you look at buyer ministries and look at sort of the concept of BNE or buyer nominated equipment. So the second is, as I am as a company getting into mass production, I'm learning this, is the wafer pricing with fabs. So let's say my friends in China get a wafer price of, let's say, $1,000 a wafer. I get a $1,500, $1,600 a wafer. And the whole competitiveness and the unit economics is determined by the wafer price. If that's something that can be done, that would be a game changer. Thank you very much, sir. Jai Hind.
Good afternoon, sir. My name is Rakesh Adhikari. I am from Insights Infotech Private Limited. Insights was founded in 2010, and from 2010 to 2024, we were mainly doing services. And in 2024, we applied for DLI, and we got this opportunity. And now we are proud to say that we are designing the India's first LED driver chip. Right. So our first product is linear LED driver. So it is basically 9-watt bulb which we are designing. We have already taped out this chip. See, this is a high volume and low margin product, and it is basically 100% imported currently from China, and all from Chinese companies. And our competitor in China, they are designing it. They have a 1 mm square chip, right? So our target when we started this project was to make it less than 1 mm square chip, right? So I'm very proud to announce you today that we could make it 0.98 mm square with 2 registers, saving 2 registers, onboard registers, and putting those registers on inside the chip, right? So so this is our first chip, and we want to be in our roadmap. We want to be so currently we are designing the 9-watt bulb, right? Later on we want to do chip for tube lights, then chip for street lights, then chip for automotive segment as well. So we want to be in this LED segment. Yeah. Our products be mass produced in SCL Mohali? Yes, sir, but they don't have this 500 nanometer technology. Actually, so far, so this product requires ultra high voltage USB process, right? Which is directly taking the 220 volt and converting it to low voltage, right? So it's not that, but yes, if it can be upgraded, this can be really game changer. So this is the picture of real picture of my layout, which we have taped out to foundry. It is 0.98 mm square, and we would be getting the samples on 15th of Feb next month. So it has huge market size. 2 billion plus chips are imported every year from our neighbor country. So the support which we need from government is to make it, basically, we have achieved the target area. Now, for selling, we would be requiring the support. Thank you very much, sir.
So, good afternoon, everyone, and especially thanks to Ashwini Vaishnaw ji for giving us more time on the desk. That is the number one thing. and Amitesh Kumarji sir as well, and all the other people from CDAC and my team who've made this possible. So I am Shashank Kumar. I am the CEO and co-founder of Multi Nanosense Technologies. So this is like a slight different flavor to this room. So we are also a sensors primary company, wherein we are working on MEMS-based sensors as well as other technology sensors for gases, wherein we are looking at different kinds of toxic gases, explosive gases, combustible gases. We've got a industry horizontal use case across multiple sectors. Just a brief background about us. We have already commercialized our solid state electrochemical hydrogen sensors. We are even exporting to about 45 customers in Australia, US, and Europe. And our journey with the semiconductors started off actually with IIT Bombay, wherein we were supported by the INUP program. We made our MEMS chips there. We proved them out. We wanted to go into a production level. International foundries were proving to be a real problem. So then we went to SCL. And we went to SCL. SCL actually helped us out. We successfully taped out our MEMS chip at SCL. And today, like that chip, we've converted it into a product along with onboard electronics. And we have sold those sensors for a hydrogen ICE engine truck to Tata Motors. This sale happened just in the last month in December. And now we are a DLI applicant. We got the approval in about August of 2025. So we are now building next gen of these MEMS gas sensors as one chip. And we have a dedicated AFE SoC, which we will combine with this. And we will be targeting multiple applications. We are going up against the biggies of the world who are in the Honeywells and ABBs and all these kinds of people in the world. They are our competition, and we have the ambition to beat them. And extremely high performance, extremely better sensors in terms of the size, the functionality, the kind of use cases that we can go around. We recently raised a 25 crore round from Mr. Ashish Kacholia, and this is what is coupling along with the DLI that we have, so we're able to leverage both these sources. And we got several POCs lined up with the biggest names in the country: oil and gas, power generation, transmission and distribution. So several use cases for hydrogen safety, methane safety, pipe natural gas safety, predicting thermal runaways in lithium-ion batteries. So wherever new energy, wherever new sources of energy storage, energy generation, energy transportation are involved, there are issues of safety, process optimization, asset health monitoring, tracking them, smart grids where you want to ensure whether transformers are good or bad or whether they're going for a toss. So those are the kinds of things we can do with our sensors, and coupled with the AFE SoC, it becomes a really, really powerful device, really miniaturized. We are able to beat people on cost, beat them on performance, as well as beat them in terms of the overall deployment possibility. So that's just a short thing about us. A few help that we would actually require here is, once we have these products out there, like volume is the biggest thing and government is the biggest consumer. So we would request if there can be some sort of engagement where we can get a POC, then merit decides what happens. But we get POCs with these government departments, which can probably be promoted by the DLI group. That would be really helpful for us to make these products actually speak in the market, and then we compete on a toe-to-toe basis with whoever is there. And like today in India, at least, we are the only company who make these sensors in the country. Rest everyone is just importing. They are all imported sensors. Nothing is made in the country today, except what we are doing. So thank you. Thanks for the time.
Good afternoon, sir. We are Green PMU Semi, a fabless semiconductor company with focus on building analog and mixed signal IC solutions. We have had an experience of working on legacy nodes of 180 nanometers, and we have done some IPs for some customers in advanced nodes of 4 nanometers also.
Through DLI, we are building an indigenous energy harvesting IC solution. You know, today, a lot of IoT devices, low power IoT sensor devices, which are limited by battery. Now, we want to extend the battery lifetime by using energy harvesting technology. There are two ways. Either you extend the battery lifetime of the system, or you can make the system autonomous in itself. The primary source of energy around us, you see the illumination in this room, which is solar, temperature difference in industries, or the vibration across the industrial machines to proactively monitor them, or the RF waves around us. So you want to capture this energy and translate that into a usable voltage, which could extend the battery life of the system. So through DLI, we have done a dual source, dual input energy harvesting IC. We do have a single input energy harvesting IC in the market, but the first dual input DC source energy harvesting IC through the 4 tape outs, we have done and we validated the chip. The next step is to take this chip to the customers, get it validated in the system first, and take it to the engineering volume. So roadmap ahead is along with this for the dual input sources. We want to validate this for the AC input sources, which are vibration as well as RF. We do have a chip demo if you want to really see that. The chip we have built, like you said, this is the solar panel. And this is only input information. You can actually see the voltage generated even for so much, like such a small energy here. This is for the DC inputs, and maybe going forward, we can live vibration. It's like let me immediately see. So the equipment so things like a lot of sensor companies, IoT companies, we want to see if we can also be a second way to be integrated so that we can have an advantage on top of whatever production which we get in any medical application, any industrial application we want to bring in that. And yes, thanks a lot for the feedback. We are a young company is starting out from Hyderabad, and the support and handholding has been dominant for us, and we hope to take this forward to a leap. And like I said, market sensor deployment, this could be the critical to add on advantage where the battery is a bottleneck, and we want to extend that battery and make it a Thank you so much.
Good afternoon, Honorable Minister and everyone. So I'm CEO and founder of Sofoscience Technology. And before dwelling into what we are building, I would like to thank for two things which people don't talk about is we have spoken about the DLI tool support, and just give you background mine. Like I was in Europe and building chip for early cancer diagnostic, and there also there is a thing called Europractice. But the uniqueness about the India DLI EDA tool is that you can commercialize your chip, but in Europe you cannot do that. For that you have to pay a lot of money. So that is what an EDA tool is really backbone for every semiconductor company. So that is why I'd like to thank this is a great opportunity given by the a young company like us. We just recently started 6 months to 8 months back, and we are able to build the chip, and we are going to tape out in April this year. And apart from that, DLI give the credibility, even though we don't have the chip right now, and we had the just idea, and because of the credibility, we got $2 million funding from Blue Hill VC also. So these kind of stuff will give you, power you, not only with the tool only, with the manpower also, where you can build a very unique technology which can empower India and also for the globe also. So I'll just walk you through what we are doing is, so at Sofoscience what we are building is first of its kind in India. We are building a biomedical chip where all the world is moving towards edge AI and everything. We are working behind in backdoor, and we are giving them a data where they can do the AI. And that is very important, because if you have a very good AI processor, if you don't have good data, you cannot do anything about that. And that is where Sofoscience Technology is building. First product is a biomedical wearable chip, which will be very ultra low power, like less than 100 microwatt we are talking, which can empower any wearables, which will be used mainly for your diagnostic of your vitals and everything. And we have already like potential customer in India, wearables, and also in UK. So the good thing is people are recognizing these kind of things, even though we are just very early phase, but they are ready to do POC by end of this year. And we have already filed so many patents, and we are in the process of filing patents. So that is all about. And looking at the timeline, what we are building, and as my background comes from the chip which we have built in past, like first of its kind for cancer detection, and that is where we will go after this. We'll build a lot of health application devices, which never happened in India. So thank you for supporting us. And one on lighter note, like in Europe, you cannot call or text anyone if you have a EDA tool problem, but here you can text to Dr. Abhay and he will get solved. Thank you.
Big round of applause for Siddharth.
Ravi, you're coming. Okay.
Good morning, good afternoon, everybody. Before I go, I'll quickly talk about, when we talk of MMRFIC, it's basically acronym for millimeter RF. So why we started in 2014, and through the minister and the departments, I would like to first thank the government of India for whatever we have achieved so far. Beyond MeitY, beyond the departments here, thanks to them, and beyond them, it's been a wonderful journey for us. And so why did we start this company? We started because we wanted to make millimeter RF an Indian capable product component, from all the way from component to products. And so far, since the beginning, from 2014 onwards, we have pretty much come to a scale where we started with founders from TI, and we headquartered in Bangalore with 70 plus employees. And since the time we started till now, as a deep tech company, we have developed many products which is purely built to spec. What we mean by built to spec is all making a design in India, make it as a product, and take it to the scale where it can be productized. And the market we are focused is primarily on the strategic market so far. So defense is our major focus at this point in time. Though we have communication as a background and connectivity as a background where we can do IPs, like Minister told right now, we are in a position where we can scale from going beyond defense to other areas as well. So, so far we have patented almost 10 concepts in millimeter wave systems. And since the inception, we've always been focused on cash flow. We have worked on making products that can generate revenue and scale the development. And more importantly, we have been invested strategically by an Indian company, Sansera Engineering. It's an Indian public company, and they have been invested in us since 2023 to scale the products, which I'll quickly cover. So what we have done, we have always been an IC company. We started doing ICs way back from 2014, and the first IC which we did in silicon germanium was a W-band. It's in the frequency of 100 gigahertz. We can say that in India, India is one of the probably 3-4 countries across the world where IC of this magnitude in W-band has been done. And today, when we visited the RDC yesterday, there were missiles and seekers shown as a display from that has been developed. And very soon we'll be happy to know that the seeker that we have done, the components for the seeker that we have done will be pretty much going into production and taking it, being part of a display in the coming years in the RDC. So I'll just because it's not related to So what we did next is, beyond IC, we need to also make products. Unless we make product and solution, there is no way we can scale the volume of the IC that we do. And that is what our focus has been from 2016 all the way till 2022, where we developed our own indigenous radar for the defense market. What you see in the corner is a surveillance radar, which we developed, and it's being used by the PSU in the country for productizing it. So this has been our journey. So coming to DLI project, having done for the last 7 years or 8 years components for the market, with DLI coming in, we are probably one of the last entrants into the DLI scheme, thanks to all the committee members, CDAC, DLA, MATI, for giving us the opportunity. This product also is for defense and space. Both these are areas where components that we make, unless we are having indigenous solution and indigenous control of the components, scaling the products, scaling to volume will be always challenging because of restrictions, because of import restrictions that may come later on. So by doing this kind of products, and this is a beamformer chip that we have proposed and doing it in the carbine, and the focus is today both DRDO and ISRO are two companies or two entities who are looking at this product. So by indigenizing and making the chip in-house, this is going to enable us to take to production and have control on the Make in India program of the country. And we just started in August or September last year. And today we are looking at the first test chip tape out in silicon germanium in FY 27-28. And I, on behalf of my team